So in this section, we just want to cover a couple applications problems, and that we want to look at the idea that the derivative, which we've already looked at before, is the rate of change, right? So if I have an application where the function is a position, where this thing is a position function, then the derivative of position is going to be the velocity. Right? If you want to say, well, how is the position changing as the object moves? Well, that will be described by its derivative, and it'll be described by the velocity function. Right? If this is measured in feet, if position is measured in feet, velocity is feet per second. And then in addition to that, the second derivative of the position function, which would be the derivative of the velocity function, describes how your velocity is changing. And if you think about that, that would, if the velocity change, that means the velocity is getting bigger or getting slower, then it's going to be the acceleration, right? That's going to tell you how the velocity changes. Okay, something else to think about, speed. We'll use speed in terms of just how fast it's going. So that's not like a two-dimensional thing or a vector thing. It's just a scalar value that it doesn't indicate direction. So if you ever asked about speed, it'll be just the absolute value of velocity. So when we talk about velocity, then if we'll usually define, like, this is we're going to do two problems, but this problem, something's going like back and forth, horizontal motion. So if you go to the right, it's positive velocity, to the left is negative velocity. Okay, and then the next problem we're doing is going to be an object that goes up and down. So up would be positive velocity, and down would be negative velocity. If it's moving down, then the velocity value will be negative, depending, like, based on how we set the function up. Okay, so you don't really have to worry about that. It should work out when we do the math, as I'll show you here in a minute. Okay, so this first problem, it has to do with horizontal motion. So you can think about it as on, like, the number line, like this. I know this is the tricky part, is this is a quadratic function that will give you the position. So, like, let's try and understand this. Where is this thing after 1 second? So it starts here. Let's say this is 0. All right, it's valid for 5 seconds. So after 1 second, it's at -4. So it went that way, boom, in 1 second, and it's here. Okay, so that means the velocity should be negative over that interval. Okay, but the position, where is it? We didn't do calculus yet. It's at -4 on the number line, if you want. All right, so if we graph the position function, this one should be pretty easy to graph. I know that's a parabola. I can come up with the intercepts real quick. One's here, right? If from algebra class, if I ask you to graph this thing, you might factor it. You say, oh, one x-intercept's here, and one's at 5. And then we could find the vertex if we wanted, but I'm pretty sure that's right in the middle at 2.5. So it'd be like 1, 2, 3, 4, and that should be t is 2.5. Okay, so I know this is the confusing part, is this is the position function, but it's giving you the position in horizontal motion. Okay, so that means as I move along, after 2 seconds, where would it be? Well, if I plugged in 2, this will give me the position. That's 2 squared minus 5 times 2. So that's 4 minus 10, so that's -6, so it goes back further. Okay, but let's just see what kind of questions we have to ask. So the idea here, so this is the position function, right? And it would continue up, but I didn't draw it up because it's only valid for 0 to 5. Okay, so that's the position function. So let's see what kind of questions you're going to be expected to answer from this guy. First, we want to graph. Well, let me bring him in here. Okay, so let's see if we can answer these questions. Graph the velocity function and determine when the object is stationary, moving to the left and moving to the right. Okay, good. So this might help us with that. So what's the velocity function look like? So let's dive into the calculus here. So the velocity function, first we need the velocity function in order to graph it. It looks like that, and we know how to graph that. That is a line. So 2t minus 5, and we're still on 0, 5, so that would start at starts at 5. And then you would go over 1. It ends at t equals 5, so this is still t. Now this is the velocity graph. This was the position graph. So you go over 1, up 2, over 1, up 2. We should hit there. Over 1, up 2. And then if I wanted the last one, I guess I could plug in 5 to be sure. 2 times 5 minus 5 is 5. Okay. So it starts at negative 5, and that's not terrible. It's not great. Let's try and get a better line here. Okay, so that's my velocity function. Okay, we'll do this a lot in here. Position function, velocity function. And this one's a little weird in that it's describing horizontal motion, so this thing's just going like right and left. All right, so the question is, when the velocity is positive, it's moving to the right. So before we answer the questions, this object is, the velocity is negative. S prime of t is the velocity. You can use either one, which is 2t minus 5. If I set this to 0, think about this for a second. What happens when I solve this? T equals 0, when the velocity is 0, what does that mean? So that is, I'll add 5 to both sides, solve this real quick. T equals 5, then divide by 2, so 5 halves right here, which we already saw in the graph. So the velocity is 0. What happens when the velocity is 0? That means the object stopped. Okay, so what was happening here, it appears, is that the object was moving backwards, and somewhere it stopped, and then it started maybe going this way. So like, for example, if I looked at s of 3, that's 3 squared minus 5 times 3. That's 9 minus 15, which is negative 6. Okay, so that's weird, right? So it went, after 1 second it went here, after 2 seconds it went here, and after 3 seconds it's back here. But that means I think it probably went back and then starts coming this way. Right? If I look at s of 4, it would be 4 squared minus 5 times 4, which is 16 minus 20, and now we're back at negative 4. Okay, so we're moving back to the right. So if you're moving to the right, the velocity should be positive, and that's what we see here. Right? So it moved to the left for 2.5 seconds because the velocity was negative, and then it's moving to the right. Velocity is positive. That means it's above the t-axis. Okay, so based on just this, we don't even need to look at this graph or this thing. We can say, based on the velocity function, it's moving left because velocity is negative on 0 to 2.5. And then that's when the velocity function goes positive, which means it's moving right on 2.5 to 5. And it's stopping, the object stops when the velocity is 0. So it goes back, stops. We didn't find out what point that was, and then it starts going that way. What other questions are we going to look at? This is similar to homework problem. Okay, acceleration function. So this is interesting. What's the acceleration? Well, it's the derivative of that thing. All right, so that means the derivative, the second derivative, acceleration is the derivative of the velocity. You don't have to write all this, but just to keep it in your head, is the second derivative of the position function, which for us is going to be an easy one to take. It's 2. Okay, so acceleration is 2. What does that mean? Do we have units? Let's bring units in. I think it'll help. Time in second, in feet. Okay, so S is in feet, so it moved 4 feet this way. That's 4 feet. Velocity is feet per second. Okay, so it's moving to the left measured in feet per second, and this is constant. So we know the acceleration is how the velocity changes. So the acceleration is constant. It's always moving at 2 feet per second squared. Okay, and that's positive. So what does that mean? Okay, so it's moving to the left, but the acceleration is positive. So it starts moving. When it starts moving this way, it's actually slowing down. You can think of it as like the momentum is gradually going this way, right? So the function goes this way, but it's slowing down to the left, and then it stops. It stops at this position. We never found this one. S of 5/2, which is 5/2 squared minus 5 times 5/2. 5/2 squared minus 5 times 5/2, which if you do the math there should give you negative 25/4, which is what? That's 6 1/4. So that means it made it back, and we kind of saw that it goes back, makes it right here, and that's where it turns around. So it's going this way, but it's kind of, think of it being like pulled to the right. So it's just slowing down because the acceleration is positive, which means acceleration is a force going that way. But it starts moving this way, but it's being pulled to the right, slowing down, hits here and then goes this way and then starts speeding up because the acceleration is constant, which describes how the velocity is changing. So it slows down and then turns in the positive direction and then it speeds up. Okay. In the next video, we'll take a look at up and down. I think up and down is a little more straightforward, as this position function will make more sense to us as we don't have to think about the horizontal motion.